Imagine standing on the shore of what is today the Mediterranean Sea and looking down, not toward the horizon, down, because 6 million years ago, where today there's water as far as the eye can see, there was an abyss, a salt desert 5 kilometers deep, deeper than the Grand Canyon multiplied by 7, stretching from the coast of Spain to the beaches of Turkey, from the south of France to the north of Africa, in absolute silence and under a sun that at the bottom of that gigantic hole generated temperatures that no living being could have survived. The Mediterranean, that sea we consider eternal, that appears in all the founding myths of Western civilization, that bathes the coasts of 20 countries, and that millions of people visit every summer without thinking twice, did not always exist. It disappeared completely. It evaporated, and then it came back. And the way it came back is so violent, so unimaginably brutal, that when geologists reconstructed it for the first time in the 70s, several of their colleagues simply did not believe them. What I am going to tell you today is one of the most extraordinary stories the Earth has produced in the last 10 million years, and I guarantee that when you finish this video, you will never look at the Mediterranean the same way again. If you are interested in the history of the planet told the way it should be told, subscribe now and hit the bell, because this is exactly what we do here, and you cannot miss what comes next. To understand how a sea disappears, you first have to understand how one works. The Mediterranean Sea is, in geological terms, an evaporation sea. This means it loses more water through evaporation than it receives from rainfall and from the rivers that flow into it. The water deficit of the Mediterranean is enormous, on the order of 1,000 cubic kilometers of water per year. What keeps the sea level stable is the Atlantic, which continuously pumps salt water through the Strait of Gibraltar, which is the only connection between the Mediterranean and the open ocean. Without that connection, without that constant flow of Atlantic water that compensates for the evaporation, the Mediterranean simply dries up, more slowly than you can imagine, but with absolute mathematical certainty. And that is exactly what happened 6 million years ago, in a geological period that scientists call the Messinian, when the tectonic plates that move the continents at the speed of your fingernail growth closed the corridor that connected the Proto-Mediterranean with the Atlantic, not all at once, gradually, but the result was the same. The process began approximately 7 million years ago, when the collision between the African and Eurasian plates, the same process that is building the Alps and that over the last few million years has raised the Himalayas to heights that 200 million years ago would have been impossible, began to elevate the terrain in what is today southern Spain and northern Morocco. At that time, there were 2 corridors connecting the Mediterranean with the Atlantic. One passed through what is today southern Spain, through the current provinces of Granada and Malaga, and the other crossed northern Morocco. As the terrain rose due to tectonic pressure, these corridors became narrower, shallower, more easily blocked by the sediments that rivers carry from the mountains to the sea. Approximately 6 million years ago, the last corridor, the Moroccan one, was blocked. The Mediterranean was isolated from the Atlantic, and it began to die. The first signs of isolation were changes in salinity. When a sea loses its connection to the ocean and continues to evaporate, the water leaves, but the salt stays. The concentration of salt increases, and with the increase in salinity, extraordinary things happen in marine ecosystems. Species that cannot adapt to hypersaline waters begin to disappear. Corals die. Fish migrate toward the few areas where fresh water from rivers still arrives. Microbial communities that tolerate salt, the same ones that exist today in the Dead Sea, begin to proliferate and dominate. The Mediterranean of 6 million years ago gradually went from being a sea of extraordinary biodiversity to being a hypersaline lake, increasingly hostile to complex life, in a process that extended over thousands of years before the final evaporation completed the emptying. And then came the silence. The Mediterranean evaporated, not all at once, not in a year, not in a century, but over a period of tens of thousands of years, during which the water level dropped meter by meter, kilometer by kilometer, until what remained was a gigantic salt basin, a dried-out pan of continental dimensions. The geologists who study this period, known as the Messinian salinity crisis, have found at the bottom of the current Mediterranean layers of evaporites, which are the mineral deposits left when salt water evaporates, up to 3 kilometers thick in some areas. 3 kilometers of accumulated salt. For reference, the Eiffel Tower stands 300 meters tall. 10 Eiffel Towers stacked in salt. That is what the Mediterranean left behind when it evaporated. The bottom of this dried basin was neither flat nor uniform. It was a landscape of extraordinary geological complexity, shaped by the same processes that had formed the previous seabed and now exposed to the sun and wind directly for the first time in millions of years. The rivers that previously flowed into the sea, the Rhone, the Ebro, the Nile, the Pah, suddenly found themselves with nowhere to go. The base level of these rivers, which is the sea level at which they empty, had dropped 5 kilometers. And when the base level of a river drops that dramatically, the river responds in the only way it can, by digging. With energy multiplied by the extraordinary slope it now faced, the Nile carved in northern Egypt a canyon that modern geologists have identified beneath the current Nile Delta, and that was comparable in size to the Grand Canyon of Colorado. The Rhone did the same in southern France. They were rivers that were no longer looking for the sea. They were looking for the bottom of a basin that was 5 kilometers below any point they had ever known. Here I need you to stop for a moment and write to me in the comments what you are thinking. Does this seem incredible to you? Did you know that the Mediterranean had completely disappeared at some point? Write to me because I want to know how many people watching this video arrived with no idea that this had happened. And your comment also helps the algorithm bring this story to more people who deserve to hear it. Write to me down below. The Mediterranean salt desert lasted approximately 600,000 years. 600,000 years of a landscape that does not exist anywhere on Earth today, because there's no place on Earth today that has the dimensions of the Mediterranean and the depth of its basin and the climatic isolation that situation would produce. The bottom of the basin, at its deepest points, was nearly 5 kilometers below the current sea level. At that depth, even at Mediterranean latitudes, conditions are extreme. The atmospheric pressure at the bottom of a 5-kilometer depression is significantly greater than at sea level. The temperatures at that bottom, exposed to the North African sun without the moderation of the seawater, could reach values that would make any known terrestrial ecosystem uninhabitable. It was a geological hell of continental dimensions, and it lasted longer than the human species has existed. But the story has a second part that is even more extraordinary than the first, because the Mediterranean came back, and the way it came back makes any disaster movie you have ever seen in your life look like an animated short film for children. Approximately 5,300,000 years ago, the Atlantic corridor opened. Geologists debate to this day whether it was a gradual process or a sudden catastrophic event, but the most recent data points to something in between. A slow initial opening that at some point reached a point of no return, from which the process became exponentially faster. Atlantic water began to enter through what is today the Strait of Gibraltar, but the Gibraltar of 5 million years ago was not a strait. It was a rock barrier that the Atlantic water began to erode from above, the way water erodes a dam when it overflows. And when the rock gave way enough, what happened was not a flow, it was a waterfall. The calculations of geologists who have modeled this event, published in top-tier scientific journals over the last 15 years, produce numbers that the human brain struggles to process. At the peak of the filling, Atlantic water fell onto the floor of the Mediterranean from a height that in the most conservative models exceeds 3 kilometers. For reference, the highest waterfall in the world today, Angel Falls in Venezuela, has a drop of less than 1 kilometer. What entered through Gibraltar 5 million years ago was a waterfall that would have made Angel Falls look like a faucet with low pressure. The flow rate that models estimate at the peak of the filling is several orders of magnitude greater than the flow of all the rivers in the world combined. The Mediterranean, according to these estimates, filled completely in a period that the most recent studies calculate between months and 2 years. Not centuries, not decades, months. A sea of nearly 2.5 million square kilometers, filling at a speed that human beings have no reference to imagine. The effects of this filling on the planet were not only local or only geological. The mass of water that entered the Mediterranean basin in that period redistributed weight on the Earth's crust by an amount sufficient to produce isostatic responses, which is the technical term for describing the sinking or rising of the crust under the weight of water or ice. The coasts of what are today Spain, France, Italy, Greece and northern Africa sank under the weight of the returning water. The ecosystems of northern Africa and the Iberian Peninsula, which during the 600,000 years of Mediterranean desert had colonized what was the seafloor with flora and fauna adapted to extreme conditions, were destroyed in a geologically instantaneous time. And the climate of the planet changed because the full Mediterranean acts as an enormous thermal regulator that moderates temperatures across Europe and northern Africa. And its absence for 600,000 years had produced continental climatic conditions in regions that today have temperate climates thanks precisely to that sea. What I find most fascinating about this story, and what I believe makes it so relevant beyond its simply spectacular dimension, is what it tells us about the permanence of the things we consider permanent. The Mediterranean is for us such an established, such a definitive reality, that it is almost impossible to imagine that it did not always exist. The civilizations born on its shores, the Greeks, the Phoenicians, the Romans, the Arabs, built their identities around that sea in the same way that we build our identities around the landscapes we have known since childhood. And yet, that sea that seems so eternal was absent for longer than our species has existed on the planet. It disappeared. It came back. And at some point in the geological future, when the collision between Africa and Europe has advanced enough to definitively close the Strait of Gibraltar, it will disappear again. Not in our lifetime. Not in the lifetime of any human being, but it will disappear. Geology has a very effective way of reminding us that the timescale on which we operate as a species is a minuscule fraction of the timescale on which the planet operates, and that most of the things we consider permanent are simply processes that have not yet finished. There are submarine canyons carved by rivers that were searching for a bottom that was 5 kilometers below. There are the sediments of the most violent filling that any ocean basin has experienced in the recent history of the Earth. Before you go, I need you to answer something in the comments. If you could have been there at the exact moment when the Atlantic began to enter through Gibraltar and the Mediterranean started to fill, from what point on the planet would you have wanted to watch it? From the hills of what is today southern Spain, watching the water come down the waterfall, from the bottom of the salt desert, if you could somehow survive there, or from space, to watch the basin fill from above? Write to me, because the answers people leave to questions like this always surprise me. And also your comment helps this video reach more people who deserve to know this story. And if you want to keep traveling through geological time, the next video takes you to another moment when the planet did something that no human being could have survived to tell the tale. See you there.